This is an LCR T4 component tester which I just bought off eBay for a very inexpensive price. The unit itself is $5.96 and $4.60 postage to Australia, and I also got the acrylic case for it because I thought that having an exposed PC board with surface mount components and a liquid crystal display is going to be a bit fragile. So this is the case made out of Perspex, covered in the adhesive paper to stop it scratching. So those are all the parts to the case, and in the anti-static bag is the unit itself. So what it consists of is the liquid crystal display, zero insertion force socket. You can also test surface mount components on these pads here, push button to activate it, and as we'd expect, a multi-pin surface mount IC and a crystal that drives the whole thing. So I'll put it together and see how good this is. Unfortunately, I have discovered that there is a break in the liquid crystal display up in the top left hand corner. So it has not survived the postage. Okay, so now I've got to go through the awkward procedure of contacting the seller on eBay and seeing if I can get a replacement. Well, I've got the replacement tester. The eBay seller was true to his word and replaced it without any difficulty. A couple of things. I've put it into the acrylic case. Now, just a couple of words of advice here. The hole in the front panel for the button needed to be reamed out because, the alignment of the actual PC board relative to the case is not completely accurate, and that was binding. Also, I've had to make a little rectangular hole in this side panel here because of where the ribbon cable bends around from the back of the display, and I didn't want to put any pressure on that because anyone who's worked on things like portable CD players and such will know that those ribbon cables are rather fragile. Anyway, let's do some testing. So first thing is power up. It'll test the battery voltage, and we stick in a component. So into the zero insertion force socket. Okay, so 4,767 picofarads, or 40.0047, which is corrected with the Phillips color code. Try an electrolytic. Okay, so obviously you have to put the component in before you start up the machine. So 13.72 microfarads, which is within tolerance. It's a 10 microfarad electrolytic, and the equivalent series resistance is 1.4 ohms, which is very good. Okay, we'll try a choke. Okay, 370 microhenries or 0.37 millihenries, and it gives you the DC resistance as well. Now, one of the useful things about this is it can identify transistor connections. So let's put in this transistor, which has got absolutely no markings on it. So it could be anything, but I know it's one of the locally assembled Fairchild things from the 1970s, when we used to make such things in Australia. So we'll just get that in and start it up. Alright, we can see it's PNP, and the base to emitter voltage is 693 millivolts, so by that we can see that it's a silicon device, and the HFE or the beta is 57, and this is obviously a germanium type, but we'll test it just to make sure. Okay, your PNP as we thought, forward voltage 171 millivolts, so yeah, around 0.2 volts, which is the germanium yeah, base emitter drop, and the beta or HFE is 55. And next we'll try a diode. Alright, forward voltage is 768 millivolts, so yeah, silicon diode. Yeah, here's another unknown diode. We'll see what that is. Just move that across. Okay, that's a very low capacitance. Yeah, 743 millivolts, so it's a silicon diode as well. One of these Mallard lock fit transistors from the 70s. No markings, or none that I can read, but anyway, so put that in and see what it does. Alright, so we've got a silicon NPN transistor with a gain of 75. So there you have it, a very handy device. I mean, if you've got a box of unknown parts like this, yeah, you can sort of now get an idea of what you've got. But yeah, good for finding, you know, faulty capacitors, open circuit capacitors. Yeah, very handy thing to have on your bench.